the night when this massive Titanic started sinking, people rushed for their lives. Some were able to make it to the lifeboat, but some didn't. But did they just die of mere chances, or were there any factors behind their death?
Hello everyone and welcome to the ML Minds. So to answer that question, today we would be solving a project on Kaggle, which is under the name Titanic Machine Learning from Disaster. So this is one of the popular projects on Kaggle for beginners in machine learning, and today we would be beginning with the project and implementing this project together. So let's see what this project contains. So we have an overview tab which just talks about the overview about how Kaggle works and how we can submit on the Kaggle. Then the whole problem is to predict the number of passengers, or to predict if the passengers survived or not based on some certain input features that they already provided in the dataset. So we have a dataset which is divided into two parts. So the first one is the training and the second one is the test dataset. In the training set as well in the test set, we have all these columns which are the features that we have, or the details about the passengers that we have to predict if the person died or not. So we have a survival column which talks about if the passenger survived or not, and that's the target column that we would be using to train our model. Then we have passenger class, which is the ticket class that they use, which is first, second or third being the cheapest. Then we have sex or gender of the passenger. Then we have age, number of siblings, number of spouses together added. Then we have number of parents or children. Then we have ticket number, the fare that they paid, the cabin that they allotted, and the port from which they embarked or on board with the ship. So we have these three ports which are abbreviated with these three letters C, Q and S. So these are the features that we have. Then we also have the same features in the test sets, and then we have the code. So if you go to the code, we have different codes implemented from people all worldwide, and they have done it in their own way of understanding. So but today we would be solving a new notebook. So let's jump onto it. If you just pause the video, and you can also open a new notebook in your PC so that we can go together building this machine learning model today. So it will take some time. So okay, so it's been open on the Kaggle platform itself, and I'll just rename the file with Titanic ML Mine. Okay, you can give whatever name you want. So there's some pre-written codes. Okay, so it says this is already exists, so I'll just, because I have already created a file previously, so I'll use this name. You can it's just not case sensitive. So I'll just use Titanic Sync as my name, as the name of the notebook. Okay, so there are some pre-written code now. So they have imported libraries from Numpy and Pandas. Then they have some code for the path that they have in the input folder. So it will print all the files and their path along with it, which are contained in the input folder. So it's already running and it will take some time. So here below we'll see that there are three files. One is the training file, one is the test file, and there is one extra file which is the gender submission file, which is just a sample file to see how our output should look like. So the output should be like one column for all the passenger IDs and another column for all the survived values, if the passenger survived or not. So that should be our sample output. But we would be needing some few more libraries for visualizing the data set. So I'll use Seaborn to visualize the data. Then I'll also use matplotlib for plotting the data. So we have our libraries with us. Now whenever we have a machine learning problem in our hand, the first and foremost thing that we have is to understand the data and see what the data actually contains. So let's start from there only. Okay, so we'll understand the data in this section. I'll just remove this cell and I'll just import the data using read CSV command, and I'll put the path for my training file. Yeah. Okay, so my data is loaded. The first command that I'll use is .info command. So it will show us all the columns in our train data set. So we have already seen that in our Kaggle platform, so we don't have to go that over again. But we see there are null values, so it shows us the count of all the values. Since the age column has lesser values of non-null entries, so there would be some null entries in our age column, and we need to handle those null values before training our model. Then we have data type for each of the columns. Okay, so we have integer, float, object, and these three data types that we have. Now since we have our null values, we can also use command .isArray and I'll sum. So it will just find all the null values and will sum the total null values that they have. So I can see the age column has 177 null values, cabin has 687, and embark column has 2 null values in the data set. Then the next thing I want to see is what data is there in my training data set. So I need to see the row values. So for that I have .head command. So if I run it, it will show me the values inside our data set. So we have passenger IDs, survived 0 or 1, the names of all the passengers, the gender, age, number of siblings, tickets, fare, cabin, and embarked station. So if you see in cabin, we have null values here. If you want to see more values, you can just type in the number of rows that you want to see, and it will show you all the rows. Yeah. Okay, great. So I'll just remove it, and so now we have looked on what our data contains. The next thing that we want to do is understand the distribution inside our data. So how the data is distributed among itself and how those variables are actually correlated with each other. So in order to understand the distribution, I'll just first use the .describe command, again from data frame pandas, and you'll see we have count values, we have mean values. If you see, so if you see the survived column has mean values less than 0.5, that means the people who died are higher than the people who survived, and that's unfortunate. Then we have the minimum values, maximum values, and the in between 3 quartiles of our distribution. Okay, so this is just a way of looking at the numbers, but what if I need to see the visualized heat map? So that's an interesting thing that we can do here. So we have df train and I'll use .correlation function. So it will give me the correlated values, and then it will map those values to a heat map. But if I run this, it will not run. For now it will give me this error because I have categorical data as well. So for that I'll have to select the numerical columns first. So I'll just type in all the numerical columns that I have. So I have passenger ID, and I have, let's see, survived P class, survived, then we have P class. Okay, so these are all the columns containing the numeric values. Hope I have written the spellings correct. So I'll just select these columns from my training data, and I'll just store them in another variable called dfnum, and I'll use that variable to find the correlation between the data. Okay, so the error is I have not written the spelling for passenger ID correct, so I'll just copy it from here and then I'll just paste it. Okay, so now ta-da, it works. So this is the heat map, and now you don't see the numbers, you see the colors, and that's the interesting part. So we have on the vertical side the columns that we have selected, and on the horizontal side we also have the same columns. Now on the diagonal we have matching with the same column, so the correlation will always be 1. That's the highest that you can see on the heat map. And so if we see other boxes, let us see this box. So this is one of the high correlation box in the positive side. So if we see, if we have a higher number of parents or children, then the passenger would also have higher number of siblings or spouses. And that makes sense, because let's say if some passenger has high number of children, if the passenger has 2 children or 1 children, then the higher chances are that the passenger will also have a spouse, and vice versa. So that's one of the positive correlation that we can see. The next thing we can see is the relation between fare and the survival rate. So if the person has paid higher fare for their ticket, that means they got first class or second class ticket, then they had the higher chances of being survived. Basically, they were given the higher priority on the ship, which was unfortunate. And so yeah, the same you can see here. So it's just opposite. And now let's see the negative correlation. So we have a strong negative correlation between the fare and the passenger class, and that doesn't give us much information about the passenger survival rate, because it's just common sense. If a passenger has paid higher fare, then they have got class of first class or second class, which is on the lower side in the number, so it has, that's why the negative correlation. So the same thing we have, let's see, with the age. So with the age also we have negative correlation. The people with the higher age would have got higher class, that means the first class or the second class ticket, because probably they would have earned so much while they have gotten so old. So that's one of the interesting thing that we can see using our Seaborn library. The next thing we can also see, which is alternate to this, is pair plot, and here I can just directly give my data frame and it will automatically take the numerical values from that. And one interesting thing that I can do here is I can provide a hue column, so it will color all these scatter plots. So it will plot the scatter points and it will color them based on the column survived. So if the person survived, then it will be of different color. If the person didn't survive, it will of different color. So don't mind the warnings here. So we just have to wait for our plot to be generated. So that's the plot that we have. Looks interesting, right? So again, on the vertical side we have the same columns, on the horizontal side we have the same columns, but now if you see, the blue color is for the people who died and the orange color is for the people who actually survived. So if you just simply see, you will see that the people who died are way much higher than the people who the people who died are way much higher than the people who survived. So that we can see on all the histogram plots from here. Okay, so you can also see between the relation between the passenger class and the survival rate. So if you see the passenger class is of first class, then the people who survived are higher. The best people are there from the second class, and people who died are higher. And if they are from the third class, the people who died are way higher than the other classes. So that simply shows that the people on board were given priority if they were from the first class ticket and so on. So that's a beautiful plot that you can generate, although we couldn't see any correlation between these values because they are just a categorical values that we have, and we could just observe some of the values from the diagonal elements and see that the people who died were way much higher in all, based on all the categories that we have. So that's another thing that we can plot. Okay, so that was all for the numerical columns that we already had. So we have seen the distribution between each of those columns, but we also had categorical columns. Let us look at them and see what we can take insight from those columns. So we had columns like sex, name, cabin, and embarked. So these, and ticket as well. So these are all the categorical columns that we have. So let us say we take the sex. So in the sex column we had male and female. So these are the categorical values. Now let me do one thing. So I'll just take on my whole data set and I'll select all the rows from my data set containing the persons who were female, right? So persons who were female and were on their ship, and so it will give me all the rows containing the females, and I'll just select the survived column of all the data frames. So it will give me an array of all the 0 and 1 values for the women specific rows. So what I can now do is I'll just print the percentage of women who survived on the ship using this simple matrix. So I'll just sum all the values in the row and I'll just calculate the length of that row. So it has given me that the percentage of women who survived were 74.2%. But let us see that number for the men. If I just copy it for men, I'll just remove and change the values, and percentage of men who survived were, you can also guess, so they were just 18.9%. so this was a huge difference. So the women were given higher priority on the ship, and the men who were there were almost like everyone above these percentage died. So that's one kind of insight that we can have for categorical values. Another interesting thing that we can use is pivot tables. So I don't know if you have already used them in the Excel file, but we can also use them in the Python. So that's interesting. So we can have first thing as index. So that will be the rows in my table that I'll use. Then I'll have parameter for columns. So let's say I want to use it for parent children column. Then what all values I want in this table with this row and this column would be the ticket. Okay, so we have a ticket, and how I want to find the values, I'll use an aggregate function with count as my aggregate function. Let me just run it and see if it works. So it says one required position album data, so I have not given the data based on which the pivot table should be generated. Okay, so it ran. So we have provided the data set, we have provided the rows based on which the rows will be calculated. So we have 0 for first row and 1 for the second row. Then we have columns for each of the numbers in the column parch, which is parent children. I'm just calling it for quickness. And then we have values. So these values are nothing but the counting of all the tickets that we have. So this will give me just the number of passengers who survived and who had 0 parents or children. So this way I can see the numbers based on different columns. So here I can see like for people with 6 or 5 children, there are very less people on the ship, while people with 0 parents or children were the most number of people. So that's one way you can see the distribution, and you can also do this for let's say different columns. So what all columns are left? So we have seen for name we don't need because that doesn't matter much. We have seen for sex, age, siblings, same as parch. Then ticket doesn't matter, fare, cabin. Let's see for cabin. It's cabin or embarked. So embarked is an interesting parameter. So if I've written it at a wrong place. So if I use embarked as my column, so if you see, we have 3 ports, and the people with the port name starting with S were the largest number of people. So this would be the first port, I'm guessing, on which people onboarded the ship. Then we have another ports as well. So if you also observe the distribution for people who died were higher on the first port, but again in the third port that went opposite, and we don't know the reason yet, but we'll see in later sections. Okay, so let's say I want to see this for the cabin as well. Okay, but again we have a lot of cabins on our data set, so we can't do that for there's no point of seeing those things. But let's say I want to see the values based on age. Now what it will give me is the people who died had an average age of 30.6 years and the people who survived had an average age of 28.34 years. So that's also an interesting thing that you can do. You can also add multiple columns to it. You can add like a parch column. You can add like another column that we had, which was for siblings and spouses and so on. You can do that for any values, and you can see that we have the average values shown for each of the people who survived or not. So that's another type of distribution method that we can use to see it. So now we have everything. So we have understood the distribution, we have understood the data. Let's move on to the next section, which would be the feature engineering part. So now we understand a little bit about our data. So let us start organizing the data such that we can use it for our final machine learning model. So in that, we need to see first what are the values and columns are there in our data again. So we have again these columns that we already saw. So whenever we do feature engineering, just remember one thing: we need to eliminate columns with the strings, because strings can't be used to train the models. We need to do something about these columns. Now there are different methods available. We have encoders from Sklearn library like OneHotEncoder or label encoder that we can use to encode these strings to some numbers. But these strings again do have information that is not required, because for the names we don't need the name of the person to see if the person survived or not for the unseen data. So we need to do some feature engineering on the data set containing the string values. Okay, so let's start with the first column that we saw, which is the name column. So in the name, as we already talked, there is nothing much to be used. But if you see, we have the designation of the person, Mr., Mrs., Miss. Now these information could be helpful because they somewhere represent what kind of person the passenger was. For example, he could be a married or unmarried person, or he could be a captain or some revered person. So these are some of the information that we can take out of this particular column. For that, I'll create another column in my same data frame, which is the title column, and I'll just fetch the title from the column name, or I'll just I have to use dot name dot apply, because I need to apply some transformations on this column name. So what all transformations that I'll do is I'll just use lambda x. So this x will be looped for each of the rows, and I'll first of all split the string based on comma. So I'll have based on comma, I'll have splitted string with two elements in the array. So it will give me, let's say for the first element, for the first row, it will give me two elements in the array. So it would be, first element would be Brown and the second element would be Mr. and then whatever the name, blah blah. Okay, so that's the output that I'll get from this split command. So I need to select the second element because I know that the designation would be there on the second element. Then I'll again have to split it now based on the space character, because there's a space between the designation and the name, and then I'll just select the first element, that would be my designation. So I have this transformation and I'll just run it. Okay, so it has been applied. Now I'll also add one more command to see if that has taken effect or not. For that, I'll use dot value counts function. Okay, so if I run it, it will give me the title column has 891 values. Okay, great. Then if we have sorted out with this name feature, so we'll take this title column and we'll drop this name column later on. Then we have sex. It's already pretty good. We only have 2 categories inside this. We'll use directly encoder on this column, so that's fine. Then we have age, siblings, parts, that's also fine. Then next thing is the ticket, so that's something that we have to handle. So we have letters, we have numbers, we have letters, numbers. Some tickets only have the numbers, so this could be maybe because of the port from which the passenger embarked the ship. So they have the different ticket system, or I don't know, that could be one of the guesses that I could have. So for that, let me first create another column. So I'll create a column which will have values from 0 or 1 based on if the ticket is just the number or it contains letter as well. Okay, so I'll again use dot apply function on ticket. So if I see my spelling is correct, okay, then dot apply I'll do, and again I'll use lambda x, and then it will be 1 if x dot is numeric, else it will be 0. So that's my plan to transform this column and have a new feature out of it. So if I just again type in the method to see if it works, so see, total 661 tickets were there which had only the numbers, and tickets with the letters were 230 tickets. Now maybe we can do one more thing, is just fetch the letters from the ticket and leave the numbers away to see if there is any pattern in that thing as well. So I'll have another column for ticket letter. So this will contain only the letters from the ticket, and I'll just again apply the transformation with lambda x. Now I need to split the x based on, let's see, so for the ticket I have space between the letters and the numbers, right? So I'll just use space as my splitting criteria, and then I'll take in not just the first value but all the values apart from the last value. So I'm assuming the last value is the number, and anything before that I'll take in for my ticket letter column. So I'll use -1, that indicates my last element in the whole row. Now again these elements would be again more than 1 now. So this is an array. Now I have to use dot join function so that I can convert this array into a single string. Okay, so this would be my string, and now once I have this string, you can see also we have slash dot these characters in between. So I need to remove that to simplify my lettering system. So I have what we had to remove is to replace slash, let's say, with nothing. Then we have dot replace again for dot with nothing, and then I'll also do a lowercase, so every letter is in the lowercase, and this would be done if length of the split that we have selected, alright, as greater than 0. Otherwise it should give me just 0. Okay, so that could be for a null value as well. So let's see if I have written everything correctly. So this I have joined, I have used the bracket for it, I have closed it here, then I have used replace dot lower. If length is, it should run. Okay, so it ran. Now let's again use dot value counts method to see if what is there in this new column that we have created. So you see we have all the letters from the tickets now successfully, and this 0 is for the null values or the values just with the numbers. Okay, so these are the letters. Now we have variety of letters in our ticket. It's not there any pattern that I could see. So we have like every letter has like 3 tickets, 2 tickets, 1 ticket, so it's hugely highly distributed. So maybe I'll not use this column in my final model. So I'll remove this ticket letter column from my training set later on. Okay, so for ticket I'll be using numeric ticket column, and I'll just removing the whole ticket column and the ticket letter column that we have just created. Then we have fare column, pretty good. Then for the cabin column we have different information. So we have C85, B42 and so on. Alright, and okay, we haven't used it there. So we have different cabins allotted to each of the passengers. Now what we could see is each of the cabin will have certain location on the ship. Now the cabin, let's say C85 or C100 would be on the similar location itself, right? So we could say that the cabin with the letter as the same letter, so the cabin with starting with the letter C would be somewhere in the same location. Now why I'm trying to reduce, so what I'm trying to do is I'm trying to reduce the number of categories in my cabin column from, let's say, C85, C123 to a one category which would be C. And why I'm trying to do that is when we try to encode our categorical columns, then each of the category would be one column in itself, and we don't want huge number of columns for our machine learning model. So for that I need to have as reduced number of categories as possible without losing much of the information. Okay, so I'll create another column for that. So that would be my cabin letter. Okay, so that will just give me the letter of the cabin. Now you have already understood how to go for that. I'll again use tftrain.cabin.apply function, and I'll use lambda x, and now what I need to do is I need to fetch the first character of my string. So I'll just convert this x to string, and I'll just fetch the value which is the first value we have. Okay, so that's ran successfully. I'll just again use the same function to see the effect of our new column. So that's cabin letter, and yeah, so we have these are the letters that we have for our cabins. Maybe I can just add on one thing. So I'll just write pivot table for this with the values, first I'll provide the data, then with the indexes as the survived, because that's our target variable. Then we had values, and before that we had columns. So I'll use for columns my cabin letter column. So I'll just see how this column distributes the number of people who died or survived. Okay, so this would be ticket, and the last aggregate function was count. Okay, so now if you see, the cabin with letter A had around 15 people and equal distribution for the number of people who died or not. Then so most of the people were from the N cabin, and the difference you see in this letter only. So this cabin was actually affecting the chances of people being survived or not. Maybe it could be because of its location being too far, or maybe it could be anything. Okay, so now we have everything for the cabin as well, and embarked is also pretty good, fairly categorized for now. So let us just display our new training set. So we have the old columns, and apart from that we have numeric ticket, which is 0 if the ticket is not numeric, and if it's numeric then it would be 1. Then we have ticket letter, which we will not be using anyways. Then we have cabin letter for the cabin first letter, which is here, and we also have title column for people who with the different designations. All right, this is the feature engineering steps that we would do on the training set that we have already done. But remember, on the test set as well, we have to do the same steps again, and we can't just type in all the commands again and again. So for that, what I would be doing is I'll create a class with the name of, let's say, feature engg, and I'll just define all the functions inside this class so that I can create an instance of this class and use the same functions again for the test set as well. Okay, so I'll start with the init constructor. So it will contain the self object and as well as the data we need to provide, on which we had to do the transformation. Okay, so the first function that we will have is for this title. Okay, so this would be our first function, and let's say I'll provide the function name as name title. So what I'll do is I'll just take in the column from self.data, which would be the data provided in the class. Then again I'll have to replace that here, .name.apply, and this would be my new column in my data that is provided. So I think that was all the transformations that we did. So we did in total 3 transformations, and this is our class for that. Okay, it says invalid syntax for name title. Oh, I just have to put the brackets on each of the functions. Sorry for that. Okay, so now we have our class created. Now we can simply use this class to apply the same feature engineering on our test data set as well. So our feature engineering part is done. The next part that we have to move on is the data pre-processing. So now we have our features with us. Let us pre-process the data set so that we can finally use the data for our training purposes. Okay, but before that, if we see our final data set right now, so we also need to remove these columns that we have used to create new features. So just don't forget that. So we will just do that as well on our new cell. So I'll just say that df train is equal to df train dot drop my columns that I need to drop. So they would be okay, so they would be the name column that we used, then we use ticket, I need to remove that, and then we use cabin. Okay, so these columns should be removed, and I need to provide these columns. These are actually columns, so it would be on the axis 1 and not the axis 0. So if I just run this, so now if I see my data, you see this is my final featured data. Now again, this is not final featured because this ticket letter is already there. We can also just drop that here only because we have incorporated that even if we didn't need that. Okay, so I think there should be an error. Okay, because I have already removed the other columns, so I'll just need to remove that separately. Just quickly I'll do that. Okay, and x is equal to 1. For now I'll have to comment this out. Don't worry, I'll provide you very good, well organized notebook at the end, so you don't have to worry about this confusion if you have right now. Okay, so now I have removed the numeric ticket letter as well, so we have now pretty good features for our case. Okay, so let us move on. So we have removed that as well. Now same thing we have to include in our function that we will be using for the test data set. So I have let's say remove calls function, and I'll just remove the data, and I'll not update the self.data, but I'll return the final data so that we can use it for later processes. So I'll just return self.data dot drop, and I need to drop these columns along with the column from ticket letter. But if you see, we haven't actually created ticket letter in our feature engineering toolbox, feature engineering class, so we don't have to remove that as well, since we have that in our here in the process, so we had to remove that separately. Now, why I have already not defined you or explained you the function beforehand, because I want you to see the process, how you actually engineer the features by seeing at each of the columns, and then come to a conclusion which one is right and which one is wrong, and then you put all the functions in a common class that you want to use. So that's the procedure that I want you to show, but the final notebook should not contain all these middle stuffs that we had for the training data set. Okay, so now coming on to the data pre-processing part, let me display my data again. So this is the data that I have. In data pre-processing, what we do is generally we handle the missing values that we have. So if we have any null values, we'll handle that, or if we have any duplicate values as well, we'll handle that. Okay, so we have to handle null values in our age column, in our embarked column, and yeah, pretty much, because we have removed cabin column, so we don't need to handle null values in that. Okay, so to handle that, now I'll just directly create my class because you have already understood the concept, and I'll just create the init constructor, which will again have the data which is inputted by us, and it will just assign self.data equal to data so that it can be used by other functions in our class. Now we can create a function to handle our null values, and so what this function will do is it will loop around for each of the column in all the columns which are available in self.data, and okay, and it will see if the column type that we have. So if self.data column has data type as object, okay, so that means it's a string or a categorical value, then we have to replace those null values either with the mode value, or we can just eliminate that row if you want. But now in this case I would be using mode values because I need as much data as possible for our case. So I'll just calculate the mode value first. Let's calculate that using the dot mode function. So I'll use dot mode, and I'll have to index it with the 0 index because it also contains some, it also returns some other values along with the mode values. So I'll just get the mode value, and then I'll just update the column that we have as dot fill with null values, replace them with the mode values that we have. Else, if the data is not categorical, that means it has numerical values to it, so then we can just replace the empty cells with the mean values. Okay, so it will just calculate the mean of all the data and it will just replace them with those mean values. Okay, so I'll just copy this here, and here instead of mode value I'll just use mean value. Okay, so that's the function that we have. It says self.data column.dtype equal to, okay, to compare I need to put double equal sign. Okay, So that's the function that will handle the null values. The next function is to handle the duplicate values if we have. Okay, so to handle that, there's a simple command to check if there are any duplicates. Okay, and if there are any duplicates, this will just drop duplicates, and it will just use in place equal to true. That means it will not create another new array, but it will just drop all the duplicates from the same array and use the same array for future purposes. And there's a underscore here and bracket here. Okay, so there are minute details, of course, that you need to consider, and it's just a syntax that you can refer from the internet. It's not a big deal. The main thing is you know how to approach things while creating your ML model. Okay, so it's better because even I have remembered that I missed inputting the self variable inside it. Otherwise the functions will not be able to use those variables inside their scope. Okay, so even I did some mistakes in the syntax. Okay, so I have the self in all the functions now. Now the next thing that I could do is scale the values if I want to. So I'll create another function for that, which is scale function. Now I need to first import some scalar values. For that I'll import it from sklearn dot preprocessing. Import, I can have standard scalar. So I can quickly check on the Google and see sklearn standard scalar. So we have this standard scalar that we have spelled here correctly. Okay, so now once we have the imported that thing, so we can create an object from that class standard scalar. Now let's see what we need to scale. So we have passenger IDs which do not need to be scaled because they actually represent the IDs which are unique to each of the passengers. Then we have survived P class already between the favorable range. Then we have age. So age is actually the number which is ranging from 0 to around 80. And then we have fare values as well, which is going from 0 to 800 or something like that. You can check that using the .describe command, but what I'll do is I'll just normalize the fare and age command, so and use that for our training purposes. So I'll just say self.data. I need to have age and fare. Fair enough. Then we have, okay, for what I need to do is I need to scale those. So I'll just use scale.fit transform. So it's a function that fits the scale, this standard scalar object, and then transforms the data on to that input data that we have. So it's a combination of fit and transform, fit transform. Okay, so that's again the scaling that we need to do, and I can return that because that's the last function that I have, and I need to return this value so that these values could be used for further processes. Okay, so my data pre-process is correct. I don't need this, and yeah. Now actually I'll pre-process my data. Alright, the training data that we have using this class that we have created. So I'll just create an instance from it just quickly. Deep data preprocessor equals, since the function has the same name, I'll use it here with the data as df train. Data preprocessor and data preprocessor. Okay, now I have the object. I can just use the functions from the object now. Okay, so I'll use dot handle null values first to have that effect, and then I'll use after that dot handle duplicates if there are any. Then I'll use the scale function. Okay, now the scale function is also returning me the data, so I'll just return these values to a new variable which will be train. So if I see there is some error, so what's the error we have is self.columns.self.column. So the issue is I have put everything in inverted commas and now it's considering that as string, which should not be like that. So I just remove this from everything, and yeah, hopefully it should work now. There's some another error. It says mean is not defined, so I have mean well here. No worries, I'll do that. What next? Okay, so it rain now. So now if I just use dot info function, you'll see there are not any null values inside our column. Inside any of the columns we don't have any duplicate values. We don't even we can see our data if it's normalized or not. So if you see for age, it's been normalized, and for fair also it's been scaled. All right, so now we have the scale data as well. Okay, so the next thing that we want to do is we have the data with us. We need to split that data so that could be used for our training into the X train and the Y train data. So we have so I have already pasted the code here, since it would take time for me to write this whole code again. So I just pasted it here and I'll explain to you what this does. So we have, what did we do is we had this train data set with us. Now we dropped the survived column, which was the target column, and assigned it to the X train, and we just took the survived column and we assigned it to the Y train column, right? Y train data frame. The next thing that we need to do is we have this categorical columns. Now we need to encode them to some numerical values, and in this I'll be using OneHotEncoder, and I need to import that as well beforehand. So I'll just use sklearn.preprocessing and I'll import OneHotEncoder. All right, so what this does is it just takes all the categories. Let's say you have male and female, so it will make two columns out of that one column, one with the male column and one with the female column. The male column will contain 0 and 1 values, where it would have 1 values only where the passenger was male, otherwise it would have 0 values, while in the female it would be just opposite. So the number of categories that a column will have will equal to the number of columns that will be created in this OneHotEncoder strategy. So we can just do dot fit transform on each column, but since we have multiple columns to be used for encoding, we need to use another library which is make column transformer. So what it will do is it will just make a transform based on whatever input we give it to. So the input that we have given is I want to have a encoder handle unknown is equal to ignore. That means we have used that because there could be a possibility that there are some categories or there are some values in a column in the training data set which will not be there on the test data set, or vice versa. Then if in the test data set, let's say the model sees a category which was not there in the training, then it is an unknown category, and to handle that, it will just use an ignore keyword. That means it will just ignore that value and will not use that to predict my survival rate. So that if I will not just use that, so it will give me an error in the cases of unknown categories. So that's a simple argument that I need to pass for that. So then I need to pass the columns for which I want to apply the encoder. So these are all the categorical values that I had, and I need to implement my encoder on these values, and all the other values will be just passed through. So we will have all the other columns in our data frame, but there will not have any effect on those columns. All right, so that's the transformer that I have created, and I'll just use that transformer to fit transform my training data set, and it will give me new data set with the encoded values. All right, and then I'll just convert it to a data frame again, because it will return me the numpy array, and I'll just run it and I'll show you. So this is the data frame that I have after encoding each of those values. Okay, so now we have our final data with us to be used to build the models. All right, now we can start using the models and train them for our predictions. So that's the easy part. So before this was the part that was the most time consuming. After this, you'll just be using different models and be implementing that. So what I'll be doing is I'll be pasting some of the model code here, and then I'll explain to you each of the models here, because I need to type it again and it will take a long time here as well. Okay, so I have pasted the code for all the models that we can use for this classification task. So we'll be using Gaussian naive Bayes, which is our baseline model, to benchmark to see how all the other models are doing on our classification task. Then we have the famous logistic regression, the decision trees, the k-neighbors classifier, the random forest classifier, and SVC. So these are some of the classifiers that we will be using. And in order to see the performance of the model, we'll be using cross-validation score. So it will just split the training data into training and validation data, and based on number of folds that we have given to it, it will just give us a cross-validation value. That means how that model is performing on our data set. So we can just create an instance of our Gaussian naive Bayes model, and we can just use cross-validation score, and we'll just provide the data to this along with the number of folds that we need to use for our cross-validation. And then if I just run it, it will print me the cross-validation value for so these are for the 5 folds. So each fold will have different validation and different training data set, and this is the mean of all the 5 values. Okay, so that's 75 percentage, which is good. Then we have for logistic regression 78.5. Then we have for the decision tree classifier cross-validation score of 74.7. Similarly for KNNs we have 49.9, which is pretty low. Then for random forest it should perform well. It's 80.8 percentage. Then for SVC it's 61.6. Then we also have XGB classifier, which simply uses a gradient boost technique to classify our states. So we have 78.57 percentage of accuracy of cross-validation score on our dataset, training dataset. So once we have all these values for our models, what we can do is we can tune these models and see how these models can be improved to get an improved performance, and based on the best performance values that we have, we'll just use that value to predict our test data set as well, and then we'll submit that notebook for our submission test evaluation. Okay, so I'll again let me just cut this. So I'll again paste here some of the code and we'll just see how we can use that and how that code actually works to tune those models and their hyperparameters. So now I have the code written for the hyperparameter tuning as well. So first I've imported two searching methods that will search for the best hyperparameters in our model. One is grid search CV and one is randomized search. So grid search actually searches on a specific grid that we have provided, but if that grid is too large, we can't afford to see each of those values and their combinations to check for the best values. So we need to use the other method, which is randomized search. So it will randomly pick the values and select the most optimum based on some stopping criteria that we have. Then we have another function created which is for the class of classifier performance. It will give me the best score along with the best parameters that were selected for based on this whatever search we did for their hyperparameters. Now let's start doing that for each of the models. So for logistic regression, so we are not tuning the naive base because that's the baseline that we have used it for. So after that we have this logistic regression where we have only one value. For maximum iterations it would be 2000. Then the penalty method could be L1 regression or L2 regression. Both could be seen. Then we have C value. Then we have the solver that would be used to solve this for our minimum optima, okay, for the error. So it's giving me, okay, I have still not run this cell, and I'll run this cell and I'll run this. So it's saying fitting 5 folds for each of the 40 candidates. Now how come these 40 candidates are there? So if you see, we have one value for iteration, 2 value for penalty, and we have 20 values for C. So we have one value for solver. So we have in total 1 into 20 into 2 into 1. That's 40. So in total 40 combinations will be tested, and it's saying 5 folds because for each cross validation it has, for the cross validation it has 5 folds to be tested on. So it has already done that, and the best score is 79.3. and if we check it for the baseline that we have used, it was 78.5. so it has improved around 0.8 percentage. Okay, then we can go on to the next, which is k neighbors classifier. Again, we have given different hyperparameters to it. Don't worry what hyperparameters you give, you will generally find them on some source on the internet as to what are the best range for these classifiers, and that you can use for your own hyperparameter tuning. But it's giving me 52.6 percentage, which was before around 49.9, so it's still fine. Okay, then we have k neighbors classifier. So k neighbors classifier, oh sorry, we already did k neighbors classifier. So we have then SVC. So SVC has again different parameters. It has 55 candidates and for each of the 5 folds. So let's see what was the percentage value before. It was 61.6 percentage, so it's not working. So I'm hoping that it would be somewhere in the 60 to 70 range only. So let's just wait for it to run, and we'll quickly move on to the next cell. So that's random forest classifier. So I have some hope from this classifier because it gave me the highest percentage for the cross validation score, which was 80.8 percentage, right? So now I'll tune it to see what it will give me. Again, it has a lot of hyperparameters options, and I'm using grid search, so it will go on to each of those grid values to see for the optimum value. So it will again take some time, so we have to wait it.
2000 years later.
Okay, so after waiting like almost 50 minutes now, the grid search is over. So for the SVC classifier, I had to stop it because I found it unnecessary, because it was already giving me very low cross validation score. So I just ran it for random forest classifier, and for this we had like 288 candidates. So again, it took a lot of time. So what we got is, just ignore these warnings, and these are the best score, which was 82.27. so these are the parameters that are there for our best model in the random forest. So for now I'll be using this model as my the ideal model to predict the test data set. But before that, we had a question in the beginning.
But did they just die of mere chances, or were there any factors behind their death?
To answer that question, we can use a feature importance method, which is already inbuilt in the random forest classifier. So it, based on whatever model which is trained and now it's predicting some values, that model can also see which features are actually creating some weightage to the output value, and based on that it will give us some feature importance value. So now we can see what factors are there which actually affected people who stood for the higher chances of survival or their death. Okay, so what I'll do is I'll again fit the best model on my training data set, and then I'll create a feature importances array based on let's just convert it into series, and based on my best RF, which is the model which is best fitted on the training data set, which has function of feature importances. Okay, and if I check if I missed anything, so I need to also define the index of my features, so that we know which features it corresponds to and which it doesn't. So I'll again write it, no, I'll just use how many features do we need to show among the top ones. So we need to see only the top 20 largest features, and then I need to also define what kind of plot should be there, which is a bar histogram. You see, these are all the features from lowest, this is the highest important feature, then as we go up the feature importance goes down. But you see the issue, there is no column name in our bar chart. So how do we know that which features are important or not? So for that, if you remember, when we lost these column heads was when we used our encoders. So if we go above here, you see we have still the headers. Now once we use this encoder, which is the transformer that we use with the OneHotEncoder, we lost the column values. But actually we didn't lost it, we have this and get it from the function dot get feature names out. So it will get me all the column names. All right, and now I can just assign it to a variable column name, and whatever I have this xtrain, I can just add these columns to my new data frame. So I'll just add columns as column names. So what I'm doing is I'm converting this xtrain, which was already in data frame mode, but I'm just converting it again with passing these parameters of column name. So it will give me new xtrain value with the column heads. Now if I run it, okay, it's got an explain column. I need to use columns here, and yeah, so it looks beautiful now. So we have all the column names. So if you see, the most important factors that actually led to people's death was the fare that they paid. All right, So the people who paid higher fare got survived because they were given higher priority on the ship. The people who were female were given higher priority. People with the age were given with the higher priority. So these are some of the most important criteria or factors which stood higher chances for people who survived. And then we have passenger IDs, male, again male and female affected the same thing, so in the opposite ways. Then we have passenger class, again the ticket class. Then if you see this cabin letter N stood out of all the other cabin letters. So as we also saw before, this cabin letter has the maximum number of people in this cabin, and maybe because of its location in the ship, it also affected the people's chance of getting out of the ship or getting out before the water fills in the lower part of the ship. Then we have siblings, spouses, parents, children. This again comes into the factor that people with the families were generally given more priorities because it's like losing a family is harder. So then we have ticket numeric is again one of the factors that maybe ticket people with the numeric ticket were boarded from some particular port, and that port has people with higher like fare, ticket fare paying people. Okay, then we have again cabin letters, and so that doesn't matter much. So this is actually for what we have created this machine learning model. Now let us use this machine learning model to actually predict the test data and submit this notebook in the Kaggle platform. So for that, I'll just create a new section for predicting the test data. Okay, I'll just cut it and we'll just start working on test data. Now we need to import our test data first. So we'll again use the .read CSV command, and I need the path that we use in the beginning for train dataset. So I'll just copy it directly and put it here. Now again we can just scroll up and see what all steps we did. So now we don't need to understand the data or understand the distribution. We can just directly skip to feature engineering part, where we had these new features being transformed using the current features. So if you see, we have created this class feature engineering. Now we can use this class directly on our test data set and implement the same transformations that we did on the train data set. So I'll just create this object with this test data set. Okay, now I can just simply run all the methods available. So if you remember, we had name, title, then we had apart from name, title, we had numeric ticket, then we had cabin letter, let me check if I'm writing it correctly or not. So where's my class? This is my class. So I have this cabin letter, and then again remove false. Now if you see, we are not creating ticket letters, so we don't need to actually remove that column as well, which we did for the train data set. Okay, so then I need to just copy this, and I know it will return me a new data set. Okay, so I think it should run. Apart from that, it doesn't know what is df test, and it says name, ticket, cabin not found in access. So what we did wrong? So let us just see what this dataset contains. So it contains name, ticket as well. but it says name ticket kbin not found in access, and that is why, because while defining the method in the class we didn't define like which axis are these columns on, so are these values on. So we need to define that these are on the column axis, which is axis equal to 1, and then we can run it again. So I hope it should work now. Okay, it worked. Then I can just see if my columns are transformed. So if you see, we have numeric ticket, kbin letter, title, and so we had these three, yeah, and we didn't have an ticket letter as well. So if you see, we also don't have survived column because this is a test data set, so just remember that, and we need to predict that column basically. The next thing that we did with our train data set is data pre-processing. So if I just go above and do this step as well, so there's this class. Okay, now I can just copy this class, and maybe I can just copy this text, okay, and paste it. Now I can just do it for test data. I'll just say df test null values, duplicate values, and it will be test data frame. Okay, it says data object is not callable, dataset preprocessor is not callable, and that's one of the issue that we did. So that's the thing, when you write your own code there would be for sure errors, and you need to handle, and you need to know actually what error is that and how you can handle. So it says data preprocessor is not subscriptable. That is because there's already this object under the same name as the class. So if I'm calling that class, it's considering the object that to be called, and it says that it's not callable. So for that, what I can do is I can just simply change the class name for now. So it says the data preprocess, and I have to change that here as well, so that the object name and the class name are not same. All right, so now I can use this, and I'll just run this. Now I can use this name for my class. Okay, and now it runs. See, so now we have our new test data with the preprocessed data. So if you see, the number of values are very less as compared to trained data set. We have just 418 values, and if I see the values inside it, in our test data we have age, which is scaled, fair, which is scaled, kbins, we already have kbins, so it has somehow not remove the columns from our test data set. So why is that? So we have df test, we have test feature engineering dot remove columns, and this was my test. Okay, I need to actually provide a right name to it. So it gives me df test, and now that df test should be passed, and now if I run it, those all columns are gone. Okay, the last thing that I need to do is to encode. Now there's an important point that I need to explain is, when we actually encode our categorical values to some numbers, there's some mapping, right? And that mapping is learned while training itself, and we need to use the same mapping for the test data set as well. If we use now some other mapping, let's say in the kbin, if the C letter is being mapped to number 2 or something else, then the model actually doesn't know what that number actually means. So it should have the same mapping to the same column name. So if you will see, in some cases what people do is they combine the train data and test data together, and then they like put the encoder on the combined data set, so they have a common mapping for both the train and test data, and then you can use the same mapping for everywhere. But the issue in that case is in the computations here at Kaggle, you will see that you will have the test data, but in real world situations you will not have the actual test data always. So it's better to have a train encoder than to apply the encoder on both train and test data set together. Okay, so let's see where was the place where we encoded the values. So here we did encoded. So this was the call trans, which was the column transformer that we fitted it on the X-train, and we need to use the same transformer to again predict my encode my test values. So let me see. So this I'll use to transform my X test, right? Now in this case this is just test, right, because we don't have Y test. So this is the function that we will use, and this should be the final data that I can use. Okay, now let us see what it did. So if I run it, so you again you see this already created it to a Numpy array, so I have to create it, I have to transform it to a data frame using pd.dataframe command, and I'll just do this. And now if I run it, you'll see we have different columns, but again we don't have names to it, but we can again have. Now if you see, if I write .info command, we can see the output. Okay, so now we have pre-processed the data set as well. Last thing is we already have the model that we tuned, and that was the random forest model, which was giving me the best score. So I'll use the same model to predict my Y test for my test data set. Okay, so I'll just keep it to test, and instead of using the fit, I'll use the predict function, and this would be my Y hat RF hat, because that's the data for predicted values. All right, so now we have the model as well. The next thing that we need to do is we need to save the submission file that we have in the successful format. So for that, we knew that in the samples gender submission file that they already provided, the first column was passenger ID, which is somewhere in the X test, and now we don't know actually the column names of our X test data set. So for that, what I'll do is I'll just use .head to see my headings, and I know that my passenger IDs are in this form 892, 893, so I'll use this particular index for my passenger ID values. Okay, then I'll convert it into integer. Then for the output, we have this Y hat RF that we have used from our random forest predictor. Okay, so that's my RF submission value. Then I'll just convert it into a data frame, and then I'll save it to a .csv file, submission.csv, and then I'll just run it to submit. So it says your submission was successfully saved. That's it, guys. So that was the whole project that we did. Of course, we didn't go in the continuous flow. We had our own mistakes, but that was all. That is the part of what you do whenever you have a new project. So that showed how you could actually build a ML model surrounding some data set which is provided. Now the last thing that you can do if you want is you can submit this code on the Kaggle. So for that, I'll just click on save version, save and run all, commit. But before that, let me check my notebook. So I don't want to run commands which are not required and will take time, unnecessary time. Okay, So if we see, we have SVC which is commented out, and pretty much everything. So this pair plot also took some time, so I'll just comment it out. We don't need it in our prediction values. So I'll just save it. It will just run it again, and then it will commit it to our submission. So let's just wait for a few minutes. Okay, so after a few iterations, we finally are successful in running and committing our notebook. The next thing that we can do is we can just click on this button, the version 3, that is the latest version. I can just click on open in viewer, and it will open my notebook in another window. The next thing that I need to do is I need to click this 3 dots button and just click to submit to computation. Alright, and now it will just ask for a few things, any description if you want, and if you don't want anything, just say submit, and it will successfully upload your file to the leaderboard. Alright, so it's submitted, and you can see the accuracy score that I can have is 77.5, which is higher than which I already submitted in the previous versions. So that's it. That's how we do a complete end-to-end project on Kaggle, and that's how you can do your first project on machine learning related project. And if you like the video, please hit the like button, and don't forget to hit that subscribe button if you want to see more such videos in the future. Thank you for watching.